Thank you very much. Good afternoon, everyone. My name is Rob Sherwood. I am CTO of Controller Technologies at Big Switch Networks. Today I am going to talk to you about something I call bare metal switches. And I'm going to try to convince you that they are like peanut butter and jelly. I will explain what I mean by that. But the important thing is to remember that these are two things, both bare metal switches and SDN are two good things on their own, but they are much better when they are together. And so I will explain what I mean by peanut butter and jelly. I will explain what I mean by bare metal switches. And just to give you a preview, bare metal switches are when you buy the switch hardware without the software, which is to say there is no vertical integration, and that you buy them just like you buy servers today. And then I'm going to talk about when you have bare metal switches and SDN together, like peanut butter and jelly, what does this mean? How does this help you? And I'm going to try to convince you that these things lead to faster innovation, they prevent vendor lock-in, and they result in lower total cost of ownership. So maybe first, what is peanut butter and jelly? I realize that in Japan, these things are not all that common. So let me try to explain. So this is an expression from English, and I apologize for bringing it, but I hope you will bear with me. So peanut butter is if you take peanuts, they're very tasty, and you squish them, maybe with a hammer, and put them on bread. It's very tasty, very good. But peanut butter in itself is good. People like this. As an independent thing, completely separate, you can do the same thing with fruits. You take the fruits, you squish them, and you make jelly. So peanut butter and jelly. These things on their own, both very good. But someone somewhere had the great idea of combining them to make peanut butter and jelly. And I realize that in Japan, this is not a normal thing, that this doesn't happen every day. And a couple people I've talked to have said, this is very strange. Why would someone do this? And I hope to convince you today, much like peanut butter and jelly, that combining SDN and these bare metal switches, it might sound strange, but it's actually a very good idea. And in the end, it's actually very yummy. So what is a bare metal switch? Let me try to explain this next. So we all like SDN. You are here today because you like SDN, or you want to know what SDN is. In my view, SDN is a standard-based data plane protocol. SDN is a logically centralized controller. And SDN involves open APIs to applications on the top. And so just for larger context, my company makes its money selling these applications. We have applications that you may have heard of called BigTap and BVS. I'm not going to talk about those today. If you're interested in these, please come talk to me afterwards. I can tell you lots about them. What I'm going to talk to you today is really about this switch. What happens on this switch? And so if we go and look at what switches look like today, they are vertically integrated, which is to say the person who makes the chip, the low-lying silicon on the bottom, is the same person who makes the box, which is the same person who makes the operating system, which is the same person who makes the applications and the features that run in the box. This is a stack that you would know and love. This is what runs our networks today. But this stack has not changed all that much, particularly up at the top, in 15 years' time. But by contrast, if you look at the server world, this is a completely different picture. You have multiple companies competing on the bottom. You can buy your chips from Intel or from AMD. You have multiple companies competing to build a box for you. You probably buy your servers from Dell or from HP or someone else, maybe a white box vendor like Supermicro. You buy operating systems and virtualization systems completely independent of who you bought the chip from or who you bought the box from. And then on top of that, you run all sorts of third-party applications, or maybe you even write your own. You know, people run Apache, they run MySQL, they write custom web applications. The critical point here is that each layer of this stack is independent, and that there's competition at each layer. And so I will call this box a bare metal server, meaning that you can buy this box totally independent of the software on it. You could buy the box and put Linux on, you could put Windows on it, you could put VMware on it, it doesn't matter. And so the question is, why can't we do this for our switches? And the answer is, we're actually starting to be able to do this. We're actually creating an ecosystem where this is possible. So with the merchant silicon movement, there's a growing number of startups and other companies that are building chips to do switching. You may have heard of Broadcom, Intel, but there are others that are coming along. There's actually lots of competition happening at this layer. There are new companies that are coming along who are making the boxes. Quanta is a name that many of you may have heard, Acton another. And these boxes are totally independent of what the underlying chips are. And conversely, there's actually a growing ecosystem of operating systems that you can put onto them. So I will talk to you a little later about Switchlight, something that comes from my company. But there are other companies who are actually putting operating systems here that you can buy independent of what the hardware is. And then last, on top, you think of, I'm using the word application a little loosely here. I mean the programs that run on the box. You can run traditional networking protocols. This is what, if you buy from one of these companies, you get traditional networking protocols like OSPF or BGP. Or you can actually get OpenFlow, and only OpenFlow. Or you could actually get both. You know, this new ecosystem, being able to pick one box from each level, this is what I mean by bare metal switches. You can actually buy the hardware separate from the software and potentially even write your own applications on top, exactly like what we do with servers. So quite often people confuse bare metal, this term that I have, with white boxes. And so if you think of in the server world, we have no-name white box servers, things that don't even have a company name. You have things that come from a company like Supermicro or Quanta. But they're different boxes from the brand name servers, Dell, HP, IBM. But all of these are what I would call bare metal servers. You can buy the software and put it on separately from the hardware. On the switch side, we're starting to identify these white box members. But note that this is different from the bare metal idea. The bare metal idea is you buy the hardware separate from the software. An interesting question to ask, who will be the brand name vendors that come to serve this bare metal box idea? And the interesting thought here is the companies that actually produce the bare metal switches, the servers, the ones that are actually working already in this space, I claim, and this is a personal claim, are actually uniquely positioned to also work in this space. I think that if you look at how we buy our servers, most companies will buy what I would call a brand name server because they're willing to pay a little bit extra for better quality hardware, for better support, or some reason. And this is why I think it's important to understand the difference between bare metal and white box. Because white box, if we look at how the servers have evolved, yes, white box servers exist, but most people buy brand name bare metal servers. And I think that same trend will evolve with the bare metal switches. So that is what a bare metal switch is. So that brings us back to our question of what is the value of having bare metal switches with SDN? What does this improve? And this is really the main focus of the talk. And in summary, it brings faster innovation, it prevents vendor lock-in, and it reduces your total cost. Everyone always talks about faster innovation. You hear it very often. At some level, it might not mean anything anymore. What this means to me is trying to get new products out to market faster, new features into your network faster. And one of the things that's nice about working with bare metal is that you can actually produce SDN-only devices. That is to say, if you actually do the implementation work to put SDN on a box, as well as, for example, a more traditional networking stack, OSPF, BGP, this is actually very difficult. This hybrid box is a difficult thing to pull off from a technical standpoint because you effectively have to virtualize the chip. You can think of it as this is comparable to running Linux and Windows at the same time on the same chip. Fundamentally, this is a hard thing to do. To give you an example, you can imagine taking one table out of the chip, and you can say, well, if I want to run hybrid, if I want to run SDN and traditional networking stacks at the same time, I'll give one half of the table to SDN and one half to the traditional networking stack. And so that works kind of okay. There are scaling implications, but maybe that will work. The problem is that there are also global configuration settings on the chip that can't be shared. For example, a common one is there's typically a global setting on the chip for can you egress an L3 packet from the port it came in on. And so for some applications in traditional networking, it depends on that being off. But some applications SDN depends on that being on. So it's not possible to share these things. And fundamentally, trying to implement these hybrid models on top of a chip is harder than one alone. And so this is why I say that bare metal switches really actually make it simpler to run an OpenFlow network. Additionally, the market forces are actually a very strong thing. So to have chip vendors compete with chip vendors and software vendors to compete with software vendors, this unlocks the whole ecosystem. It creates a lower barrier to entry for new companies to come in, which is to say, if I have a great idea for a better routing protocol, I don't have to also become a chip-making company and a box-making company in order to prove it to you. I can just compete at that top level. Additionally, and maybe this is a bit subtle, there's a tighter and faster development process when the people who are writing the control plane software, when people who are writing controllers, can also write the switch software, which is to say, if you think of the switch as a black box, and traditionally we've always thought of it as a black box, it's something that you can't touch. With bare metal switching, you can actually open up that black box and manage the software on both sides, on both the switch side and the controller side. Practically what this means is that you can develop features faster, and more practically you can even take things like the OpenFlow standard, which is the protocol that communicates between the switch and the controller, and evolve that more quickly and more precisely. You get a tighter coupling between the two moving pieces. So the result of this is that across these 3 points, we end up in faster innovation when we combine the bare metal switching with SDN. Another thing that I hear from concern of the customers I talk to is vendor lock-in. And combining bare metal switches with SDN actually prevents vendor lock-in. So The way that it does this is by having open standards at each of these levels. So between the switch and the operating system, there's a new standard coming out called ONIE, O-N-I-E. This is a bootloader for the operating system so that the switch box manufacturer doesn't have to support all the different operating systems. They simply support the bootloader, and much like on a server, you could then load the operating system of your choice. If you're interested in this, I can send out this URL for people to find out more about it. This is part of the larger Open Compute project with Facebook. You also have open protocols between the switch operating system and the applications. These are the protocols like OpenFlow and the OFConfig and SNMP and SFlow that we've already come to know and love. These protocols are being standardized in various standards bodies, but the critical thing is they're open. And then on this top layer, we have open protocols between the management layer and the applications above them, which is to say things like OpenStack with Neutron, formerly Quantum, if you're familiar with that, or CloudStack. There are APIs here to manage this whole stack that are separate from the chip, which are separate from the box and separate from the operating system. All of these things combine to prevent vendor lock-in, at each of these steps. Another point is that combining SDN with bare metal switches actually reduces the total cost. So I did a simple Google search for Quantum's LY2 platform. And so LY2 is a 1 rack unit switch. It has 48 ports of 10 gigabit and 4 ports of 40 gigabit. If you're familiar with these other boxes, it actually uses the exact same underlying chip ASIC. And if you, don't believe me, do the Google search yourself. You come up with prices that look like this for this box. This is a very inexpensive box. And more so, this is actually a high price. I know that if I personally talk to resellers, I can get it much cheaper than this for one box, and much, much cheaper if I buy multiple boxes, if I buy them in volume. So if you look at the comparable boxes, we're saving quite a bit of money just for this. And so this is for the hardware. On the software side, we're also reducing total cost of ownership. For example, with things like SwitchLite. So SwitchLite is a product from my company. It's effectively a switch operating system based off of Linux. It is, and maybe you'll forgive my logos here, it is just Linux with OpenFlow on it. That is all SwitchLite is. And this really tries to leverage this bare metal ecosystem. The idea from our side, we actually don't make any money from SwitchLite. The main interest, our only interest in developing SwitchLite is to actually work on feature velocity, which is exactly as I was saying in the earlier slides. Because we can write the controller and the switch at the same time, we can actually produce products faster and move faster in the ecosystem. And it's interesting to me, stepping back, that the market factors have changed so quickly that allows us to work in this space. The number of customers that are interested in bare metal switching has increased dramatically, even in the last 6 months. The other part of this that pushed my company towards SwitchLite was actually the vendor adoption rate of basic OpenFlow. So some vendors have been slow to adopt OpenFlow altogether, and even the ones that have been slow to adopt a more feature-rich multi-table versions of OpenFlow, like OpenFlow 1.3. So it's both our interest in moving faster that we have gone to SwitchLite, as well as the idea that some of the vendors have not moved, they haven't had the velocity that we have wanted. So what is SwitchLite? So at a block level diagram, it is a Linux distribution. All of the pieces here in blue our standard open source components. It includes secure shell, a fan-controlled daemon, a network time protocol daemon, syslog, standard SNMP, although we do extend some of it to talk to our OpenFlow agent. And what's unique, what we add to it, is this OpenFlow agent. It's based on source code that we've developed called Indigo, and it speaks down directly to the ASIC. So it's the only thing talking to the ASIC on the switch. You can also get Switch Lite in a vSwitch form, which is to say it speaks to a vSwitch module in the kernel and talks directly to an x86. So the thing that I want you to take from this slide is that almost everything here is open source. The only things that are not open source are the proprietary SDK that goes with the ASIC that's not controlled by us, and our driver that talks to that, which has to be closed source because of the NDA. But what this allows you to do, because it is just Linux, it allows you to reduce the total cost by managing your switches much like a server. If you want to deploy new software on the switch, you can do it just like you do with your servers. You can actually run apt-get just like you would run apt-get on any Linux machine. So, in conclusion, my claim is that SDN and bare metal servers are just like peanut butter and jelly, which is to say they are two good things on their own, but they do much better when they're combined together. Bare metal switches are hardware without the software, which is to say you buy them like you buy servers. You can put your own software on them. You could get other software. There's actually an evolving ecosystem. And combined, when you bring these two together, they're actually much better than apart, which is to say, it accelerates the feature velocity, it prevents vendor lock-in, and it actually reduces your cost. And I will leave you with what the peanut butter and jelly looks like in case you didn't have enough to eat for lunch. Maybe you are getting hungry now. And if possible, if there's time, I will take some questions now. Thank you very much.